Hi guys, welcome to 10th grade mathematics lesson. In this video lecture we are going to discuss about trigonometric ratio, trigonometric identities and sign of trigonometric ratio in each quadrant. Trigonometric functions. The sixth ratio of the lengths of the two sides of a right triangle are called trigonometric functions. Let's consider we have a right triangle ABC. Let's name this angle theta. The side AB is opposite side to theta, CB is adjacent side to theta, and AC is hypotenuse. The trigonometric ratio of angle theta are defined as sine of theta equals to opposite side divided by hypotenuse, which is in this right triangle which we have on the left side, AB divided by AC. Cosine of theta equals to adjacent side divided by hypotenuse. Adjacent side of theta is BC and hypotenuse is AC. Tangent of theta equals to opposite side divided by adjacent, which is equal to AB by BC. Cotangent of theta equals to adjacent side divided by opposite. In this figure which we have on the left side, it is equal to BC divided by AB. Secant of theta equals to hypotenuse side divided by adjacent side. It is equal to AC divided by BC. Cosecant of theta equals to hypotenuse side divided by opposite side. In this figure, it is equal to AC divided by AB. Let's have an example. Find the sine and cosine for the angle theta that is in standard position and its terminal side is passing through the point 8 and 15. At first, let's draw the point 8 and 15 in rectangular coordinate system. Draw a perpendicular line from point 8 and 15 to x-axis. Join the point P to origin. The angle which is creating that is called theta in here. Let's name that one theta. The distance of the point from x-axis is 15 units. The distance of the point from y-axis is 8 units. For finding the sine and cosine of angle theta, at first we should know how much is length of side hypotenuse. We have to apply the Pythagorean theorem on this right triangle. By applying that one, we will have x squared plus 18 squared is equal to 8 squared plus 15 squared. 8 square is equal to 64 and 15 square is equal to 225. If we add these two, we will get 289. Take the square root of both sides, we will receive x equals to 17. When we find out the length of hypotenuse, we can find out the trigonometric ratio sine and cosine of angle theta. We know the sine of any angle is equal to opposite side divided by hypotenuse. In this figure, opposite side is 15, hypotenuse is 17, and cosine of theta equals to adjacent side divided by hypotenuse, which is equal to 8 divided by 17. Trigonometric identities. You may have observed some relationship that exists among the 6 trigonometric functions of acute angles. For example, we know that cosecant of theta equals to hypotenuse divided by opposite side. We can write down that one as 1 divided by opposite side divided by hypotenuse. We know that opposite side divided by hypotenuse is equal to sine of theta. So we can write this fraction as 1 divided by sine of theta. The reciprocal identities are secant as follows. Secant of theta is the reciprocal of cosine of theta. Cosecant of theta is the reciprocal of sine of theta. Cotangent of theta is the reciprocal of tangent of theta. If we multiply the reciprocals to each other, we will get 1. Two other fundamental identities that are easy to see are the quotient identities. Tangent of theta is equal to sine of theta divided by cosine of theta. Cotangent of theta is equal to cosine of theta divided by sine of theta. We can get 3 more optimal trigonometric identities by applying Pythagorean theorem on right triangle. Let's consider we have a right triangle as we can see in the figure. If we apply the Pythagorean theorem in this right triangle, we will get a square plus b square equals to c square. Let's divide both sides of this equation by c square. We will have a square divided by c square plus b square divided by c square equals to c square divided by c square. By using the rules belong to the exponent, we can write down a divided by c whole square plus b divided by c whole square equals to 1. We can see obviously from this figure, sine of theta is equal to b by c and cosine of theta equals to a by c. We can replace the values in here. By replacing that one, we will get sine square of theta plus cosine square of theta equals to 1. Now let's divide both sides of the equation 1 by a square. By doing that one, we will have a square divided by a square plus b square divided by a square equals to c square divided by a square. By using the rules belong to the exponent, we can write down 1 plus b by a whole square equals to c by a whole square. As we can see, the tangent of theta in this figure is equal to b by a and secant of theta equals to c by a. By replacing the value in here, we will get 1 plus tangent square of theta equals to secant square of theta. Now let's divide both sides of equation 1 by b square. By doing that one, we will get a square divided by b square plus b square divided by b square equals to c square divided by b square. By using the rules belong to the exponent, we will get a by b whole square plus 1 equals to c by b whole square. As we can see in this figure, a by b is cotangent of theta and c by b is cosecant of theta. Let's replace these values in this equation. We will get 1 plus cotangent square of theta equals to cosecant square of theta. The next thing that we have to know that is about unit circle or trigonometric circle. The circle whose center is at the origin with the radius 1 unit is unit circle. Here we have a unit circle. Let's name this angle theta. The point that we have in there, that is the point P. Draw a perpendicular line from this point to x-axis. And here we will get a right triangle. If I want to define the sine and cosine of theta in this right triangle, I can write down cosine of theta equals to 1. Because we know that cosine of any angle is equal to the adjacent side divided by hypotenuse. And hypotenuse is in there, the radius of the circle. And we say the radius of circle is 1 unit. So we can say cosine of theta equals to a. And if I find out the sine of theta for this angle, I can write down b by a. b by a is equal to b. So we can say on a unit circle, the abscissa of the point is cosine of theta, means point P, and the ordinate of the point P is sine of theta. And also we should say that point P is the intersection point of the terminal side of an angle with unit circle or trigonometric circle. Sign of trigonometric ratio in quadrants. If the terminal side of any angle lies in first quadrant, the sign of all of the trigonometric ratio of that angle will be positive. If the terminal side of any angle lies in second quadrant, just sine and cosine and its reciprocal, which is cosecant, that will be positive. The rest are negative. If the terminal side of an angle lies in third quadrant, tangent and cotangent of that angle is positive. The rest are negative. If the terminal side of any angle lies in fourth quadrant, cosecant and its reciprocal, which is secant, that is positive. The rest are negative. And also, you may like to remember this one as by remembering these lines or these sentences. All silly turtles crawl. A stands for all of trigonometric ratios. S stands for sine and its reciprocal. Tangent stands for theta stands for tangent and its reciprocal, and C stands for cosine and its reciprocal. And also we have another sentence as well. Add sugar to the coffee. Let's have an example. If sine of theta is negative or less than 0 and tangent of theta be greater than 0, name the quadrant in which the angle theta lies. We know that sine of theta is negative in third and fourth quadrant. And also tangent of theta is positive in first quadrant and third quadrant. So theta lies in third quadrant. It was all about this video lecture. Thanks for watching.